So the next thing to go over in algebra tutorials is factoring. So factoring is one of the most important parts of algebra in my opinion because you use it a lot and there's a lot of different ways to do it. So it'll probably be a pretty big unit. And so today I'm going to go over basic factoring. So what is factoring? The way I broke it down was I said it was like it's kind of simplifying an expression in order to solve it. Typically you're putting it putting the equation in a position that x can be solved, and you do that by breaking down different factors or numbers in the equation. So like I said, there's many different types of factoring. I'm going to go over quadratic factoring, also known as trinomials, grouping, and differences of squares. Also, just to mention real quick, GCF, or greatest common factor, is probably the most basic way to factor. I didn't make a full slide for it because it's pretty easy. You just take out the highest number that can be multiplied by every factor in the equation. There might be an example of it later, but say if you have an equation that's like 4x plus 2, well, you could take 2 out of both 4x and 2 and be left times 2 times 2x plus 1, and that just makes it easier to solve for x. So factoring trinomials, so remember our quadratic equation, ax squared plus bx plus c equals 0. And the way you factor quadratics is you find two whole numbers or integers that have a product of a and c and have the sum of b. I like to think about it backwards, and like the sum of b, it's after you FOIL, which is how you would expand an equation like this. It stands for front, outer, inner, and last, which is like you multiply the front by the front of this part, and then you multiply the two outer parts and the inner parts, and then the last in order to get this equation. Like 5x times x, which will be the front part, will equal 5x squared. And then when you do the rest of it out, 5x times 3 is 15, 1 times x is just x, and then you add them together and get 16. And the last part is just a constant. So that's basically like you could do it backwards in your head, you could try to, and that's probably one of the easier ways to think about factoring trinomials. So you need basically what you want to find first is probably for the constant. So you need these two numbers on this side to multiply together to make the constant. In this case, 3, the only two numbers that multiply together to get 3 is 3 and 1. And then you just have to make it add up to the 16 after you multiply the opposite side. So the sum part comes from the outer sides and the inner. So in this case, x, when you FOIL, x would be multiplied by 1, giving us just 1x, but 3 would be multiplied by 5, giving us 15, which means you could combine them to make the 16x. And once again, factoring is used to make it easier to solve equations. Instead of trying to solve 5x squared plus 16x plus 3 equals 0, you have these two equations where you could just plug in, well, you don't plug in, but you solve for 0 in both of these separate expressions, giving us x is negative 1/5 or x is negative 3. So the next way to factor is grouping, and typically there's going to be a polynomial or an equation with four parts. So this is where the GCF could come into play because you group two separate parts of the equation with the greatest common factor. So you basically, the easiest way to do it is just splitting it down the middle and seeing what is the greatest common factor between the two terms on either side. So our first term here would be 12x squared plus 18x, and you could take a 6 out of the coefficients and an x out because there's an x in both of them, giving us 6x. And then in this side, you would take out a 5 because that is the greatest common factor between 10 and 15, and there's no x. And what's left over on this side is 2x plus 3 after you take out 6x. And what's left on this side is also 2x plus 3. And this is important because it has to be the same, because after you simplify it, you take on what's outside the parentheses and put it together, 6x plus 5, and then these two numbers, which should be the same, the expressions inside the parentheses, get put right here. And then after that, you could just solve for x.